So here we are adding forces again, and um, we're going to have to do this slightly different. This is one of those questions that, yeah, it's 95% of this almost is interpreting what's going on. Now, there's a couple of things to note just at the beginning. Okay, so let's read the question. Three forces act on an object so that it remains in equilibrium. That means if you add all the forces up, the answer is 0. Okay? Two of the forces have magnitudes of 65 and 125. And the angle between their directions is 80. We're going to come back to that. Determine the size of the third force and the angle, blah, 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 blah. Right. So let's firstly do a sketch. Okay, and try and get an idea, try and get a picture of what it is that's going on. Whenever you're dealing with vectors, start with a sketch. Okay. Two of the forces have magnitudes of 65. So let's do a vector with a magnitude of 65. There we go. Now it does not matter where I draw that. Okay, because these vectors are relative to each other. So I mean, I could have started off by doing that. Okay, but I'm not. I've chosen, for whatever reason, that my first vector here, force 1, is 65 newtons heading in that direction. Then we have got a second force, which is bigger. It's 125. So it's 125 heading down that way. And whenever you're adding vectors together, the arrows follow each other. When a force is in equilibrium, it means that the third force that we are trying to find, this white line here, goes back to its starting point. Okay, so this is what we are trying to find. Let's call you F3. It was supposed to be F3. And now let's hit upon the problems with this question. Okay. We're told up here that the angle between their directions is 80 degrees. And what I want to do, my instinct tells me that I should be putting an 80 in there. Okay, that's what that's telling me. But that's not what it's meaning. When it's saying that the angle between their directions is 80 degrees, what it's meaning is, if I was to actually have them all have them both start at the same point, it's meaning that angle in there is 80 degrees. Okay, because that's their directions, that's the directions that they're heading in. So for us, it's not going to be that bit in there that's 80. What it actually would be, if I just draw some lines in here, so we've said that that bit in there is 80, it means that this bit here is 80 degrees. Okay, because it's like an F shape, you know, with whoa, what was that? It's like an F shape. Okay, because really that's where we're kind of taking. I can't fit that in properly, but there we go. Okay, which tells me that this angle in here is not going to be 80. It's actually going to be 100. Now, if we select again, if you do this question and you used 80 in there, you lose a mark. Big deal. It's a 5-mark question. Okay, so it's not like it's the end of the world. But we've got our third force there. Okay, and we need to find two things. We need to find the direction and the magnitude. So let's start off with the magnitude because it's nicer. So we'll call the length of that line x. And what we've got is we've got x. We know two sides. We know the angle in between. That tells me that we're going to be using the cosine rule for this. We're going to say that x squared equals 65 squared plus 125 squared minus 2 times 65 125 times 125 times cos of 100. Now, whenever you are finding the magnitude of to a resultant or a third force in this case, you can always do that. That'll work for the question that I did earlier on as well. Although I switched it into rectangular and added them, I did that because I've taught this stuff in engineering for years, and it was always a really easy question there because we always did it like that. But you absolutely can do this. If you can get the diagram set up and if you can figure out that angle, then you can use the cosine rule. Okay, and it'll give you the exact same thing. And in fact, the answers that I show you of the previous question will do it like that. So we just plug that in your calculator. We click solve because we're using a ClassPad for it. I actually have a ClassPad emulator that I could use just now, and I could like push these buttons in, and it would all work lovely. But it's like an extra half hour of work that I just cannot face doing. So that's us figured all that stuff out. We've got the magnitude. We're halfway there. Now we need to find the angle its direction makes with the larger force. Wow, I do not know what that means. Alright, the angle its direction makes with the larger force, I'm guessing. Okay, right. I'm guessing we're talking about this angle in here. Because the largest force is 125. So we're going to have to figure out what theta is. It's not going to then be theta, but we'll deal with that problem when we come to it, because this angle in between is a little bit of an issue. But for finding theta, that's an easy enough job. Okay, we can use the sine rule for it. Because I can say that sine theta over 65 has to equal the sine of 100 over that x that we just found, the magnitude, which was 150.6. The more decimal places you use here, the more accurate your answer will be. I should point that out as well. So you go ahead, you stick that in your calculator, you click solve, you get theta equals 25.2 degrees. The issue is that the angle its direction makes with the larger force means they have to start in the same place. So it's not 20, if it's not that angle in here, hold on, let me just move that up actually, it'll make it slightly easier to visualize. Okay, it's this angle here. Okay, I should use the different colour there, so let me change that. Let's go to white. Okay, it's that angle there that we are actually needing to know here. Okay, because when you're wanting the angle between their directions, they both need to start at the same place and the arrows head out. I actually went and like pointed there, like folk could see that. So if you look at it, you can see that we've worked out theta, so it's just going to be 180, take away that. So the actual direction that it's going to go in is going to be, so you can go back up there. You can go back up there. Oh, wait, what happened to you there? Let's just quickly redraw an arrow on that. There. So the angle is going to be 180 take away 25.2, which is 154.8 degrees. Okay, so that's an alternative way just of finding, that's the only way you can do that question. But you know, when you're doing magnitude and finding angles, you can also use your cosine and sine rules, okay, depending on the question. Alright, let's now go to stopping this. Stop.